Okay, guys, so here we go. We're going to be talking about our CBA 10 review, which for on level, this is your last CBA for the year. Okay, so that's good. And we're going to be talking about these things here called box plots or box and whisker plots. Okay, so these particular types of data representations talk about basically a spread of numbers. Okay, so in order to they talk about a lot of different data points, and in order to kind of figure out what those are, there are certain ways to identify them. Okay, so we do have two people here, so that's going to be important, right? We have Jim and Suresh. Okay, so I'm going to write two names. I'm going to write Jim and I'm going to write Suresh. Okay, now they both have two different sets of data. And in order to understand what these two different sets of data means, we're going to be labeling these box plots. Okay, so let's go ahead and do that. Smallest, this furthest dot to the left is going to be your minimum, and that's going to be true for both people. Then this corner here, it doesn't matter if it's the top or bottom corner. Okay, that's going to represent your quartile 1. I'll put it down here. The dot or the line that's moving vertically in your box is representing the median. And of course, I'm just abbreviating these things here. And then your furthest, the other corner, right, to the right, that's going to be your quartile 3. Okay, and again, doesn't really matter if it's at the top corner or bottom corner. I'm just trying to make sure that the information isn't super squished together. And then the furthest point to your right is going to be that maximum number. Okay, now there's a few reasons why we're doing this. When we look at box plots, there's supposed to be what's called 5 points of data. If we include our interquartile range, then it's technically 6 points of data. So because one of our answer choices does talk about the interquartile range, we are going to do that. Okay, so first things first, we labeled. Okay, but I'm not really quite done labeling, because notice that my number line has some missing pieces of information. I know that if I go, 71, 2, 3, 4, well, that's not going to make any sense. So maybe skip count by 2, 72, 74, 76, 78. So here we're skip counting by 80, or by 2, sorry. So let's go ahead and fill in the rest. That way it's easier for us to identify what these numbers are. I apologize for my fingers here, but they'll get out of the way in just a second. Boom, there we go. Cool. So now it's a little bit easier for me to identify what our different points of data are. Okay. So let's go ahead and write some of this down. So we have our minimum, we have our quartile 1, we have our median, we have our quartile 3, we have our maximum, and then we're going to include our interquartile range. Okay. And then we'll do the same thing for Suresh. Minimum, quartile 1, median, quartile 3, maximum, and then of course our interquartile range. Okay, cool, awesome. Let's do it. Now, something that's really important to know is, how do you find that interquartile range? Okay, so the formula for interquartile range is right here, Q3 minus Q1, and that's going to give you your interquartile range. Okay, so we're really just getting those two numbers and we're subtracting them. Okay, so let's go ahead and get our information down so that we can figure out what conclusions we can make based on this data. Okay, so for our Jim's minimum, looks like it is 72. His first quartile looks like it is 76. The median is 80. Third quartile is 86. His maximum is going to be 90. And again, interquartile range is Q3 minus Q1, so 86 minus 76, that gives him an interquartile range of 10. And we'll do the same thing for Suresh. All right, Suresh looks like he has a minimum that's in between 86 and 88, so we're going to say that's 87. Quartile 1 is 92, median is 94, quartile 3 is 96, and its maximum is going to be 100. Again, interquartile range is Q3 minus Q1, so 96 minus 92 is going to give us that 4. Now, for answer choice A, it says the range of Jim's score is 10. Now, range is different than interquartile range. Interquartile range is just this number minus this number. But range is your largest number minus your smallest number. They're saying that the range for Jim's scores is 10. Well, if his largest number is 90 and his smallest number is 72, then that's a difference of 18 and not 10. So A cannot work. Here it says the interquartile range of Suresh's test scores is 13. But again, there's a reason why we solved it earlier, because we can just look at our answers and say that that's also just flat out not true. The median of Jim's scores is 80. Well, let's see. If we pull that line down, that looks like that is true. So that's what I'm going to choose. Not sure why this says the half of. Obviously, that's an error. So just go ahead and scratch that out. Suresh's test scores is between 92 and 96. No. I wouldn't say that that's half, because again, like, we would have to look at his maximum, his minimum, and then find the half of that. And it's just not going to be 94. Sorry. Yeah, that's not going to work. So let's keep moving on to number 2. Okay, number 2. There's 2 pieces of information here that's kind of really, really important. Okay. And so I had these are like key pieces of helpful information. Okay, so make a couple little stars, then I'll write down what I'm talking about. So if you have a smaller box, right? So if you have a smaller interquartile range, then you're going to end up getting more consistent scores. All right, scores. Okay, another key piece of information here is that the higher, if you have a higher median, then you also have higher scores. Remember that a higher median is going to be your average, right? So if you're achieving a higher average, then your scores by definition are going to be higher as well. So again, you can see here that on the on our number line here, it's not entirely filled out. We can see that they're skip counting by 2s. So you can fill that out. We don't need every piece of information like we just did. We don't need, I mean, we can do that, but it's not necessary for this question, just based on the answer choices. But just to have numbers where they should be, I do like to at least fill out the number lines. Okay, now, here we go. Answer choices. This says, overall, Samir had better scores than Holly, and Samir was more consistent with her scores. Well, if we look at where Samir's median is, his median is right here between 78 and 80. So his median is 79, whereas Holly's median is at 89. So Samir did not have better scores. He may have been more consistent because he does have a smaller box. However, his scores were not better than Holly's. So that just can't be true. B, it says overall Samir had better scores than Holly, and Holly was more consistent in her scores. So this one is even more incorrect. just based on the fact that it had the same exact piece of information in our top one, we know it's wrong. But then it says Holly was more consistent with her scores. But Holly's box is pretty big, whereas Samir's box is small. And the smaller your box, the smaller your interquartile range, the more consistent scores you have. So B is like double wrong. I'm not sure why they thought that would be correct. Overall, Holly had better scores than Samir. We know that's true because she has a higher median, a higher average. And Samir was more consistent in his scores. Well, we know that's true because his box is very small, which means that even though his scores weren't higher than Holly's, his scores are more consistently the same. And so C in this case is going to be our answer. All right, move on up. All right, cool. So stem and leaf plot, okay? Biggest thing here is we're talking about our key. Okay, we have a key. So 3, here's our like separation between our stem and our leaves, right? And then 0. But all that means is 30, okay? So this is 30, 31, 32, 32, 33, 36, 40, 42, 42, 43, and so forth, okay? So here, it says the stem and leaf plot shows the number of toys collected by various schools for a children's center. How many schools collected more than 47 toys? Well, okay. If we look at our data set, really, this whole data set is going to represent 47 toys, or schools that collected more than 47 toys. Sorry about that. So, just for the sake of writing them out, let's go ahead and do that. So we have a 50, we have a 51, we have a 54, a 57, and a 59. Okay, and these numbers represent the amount of toys that these particular schools collected. So how many schools collected more than 47 toys? 1, 2, 3, 4, 5. So our answer choice here is B. Not bad. Let's keep going. All right, let's talk about number 4. Number 4. Okay. It says the traffic engineer is collecting counts of how many cars are on one street during a specific time each day, and the results are shown in the histogram. Which statement best supported, or is best supported rather, by the information in the histogram? Okay, cool. Not a big deal. A couple things. I don't like that on the y-axis they have separated information, so I'm going to fill it out, right? Just again, so that when I'm looking at these bars and comparing them to the values which are represented on the left-hand side, again on our y-axis, I want to know what these numbers are without having to think too hard. So here we go. Number of cars, right? From 0 to 14, it took 3 days to see that. From 15 to 29, it took 7 days to see that many cars. From 30 to 44, it took 13 days. 45 to 49, what is that? 10 days. Good. And then our last one here is 5 days. Perfect. Now, in order to figure out, or, basically, what do we do with these numbers now? Okay, well, we need to know how many days are being represented. And in order to know how many days are being represented, we have to add all of our days. So let's go ahead and do that. 3 plus 7 is 10. 10 plus 13 is 23. 23 plus 10 is 33. And 33 plus 5 is 38. So we have a total amount of days being represented by 38. Now it's just a matter of reading some stuff here, okay? When we look at our answer choices, it says the traffic engineer observed only 3 cars in the first 14 days. Well, that's really interesting, because if I look at my x-axis here, I see number of cars. If I look at my y-axis here, I see days. Hmm. So in 3 days, 1, 2, 3, they observed 0 to 14 cars. But here it's saying that they only observed 3 cars in the first 14 days. This is wrong. Another thing that we're looking for in answer choices B and C here is there's like some weird words that they have in here. Maybe not weird, but like it doesn't make sense based on the information we have. So it says more than half of the drivers do not prefer driving on the weekends. Weekends is going to be a weird word because over the course of 38 days, obviously we're talking about weekends, but do they specify weekdays or weekends? No. So that doesn't make sense. Not only does that not make sense, it's not that we can't figure out and differentiate the difference between the weekdays and the weekends. But because we don't have that, not only is it wrong, I'm also going to say there's not enough information. Because we can find that information out, just not with the information they've given us here. Now for C, it says there more. That's a typo. There are, I think it's what it's supposed to say, more cars during the morning time than the evening time. Again, they're talking about time of day. This is talking about type of day, right? Weekdays, weekends. This is talking about time of day. They're not talking about the time of day. They're talking about a day as a collective whole. Therefore, this is also wrong. And again, it's not that we can't find the information to figure out what the difference is between the morning and the evening time. However, we don't have enough information for that. So, by process of elimination and because it makes the most sense, the traffic engineer collected data for 38 days. Okay, let's talk about 5. 5 is kind of fun because we get to build our own little dot plot, okay? So I'm drawing a little line and I'm going to match it to my numbers down here on this number line. So I'll give it a 1, 2, 3, 4, 5, and of course 6, right? Cool, awesome. Number 5 says Mrs. Samuelson records the amount of time each of her students spends studying each week. Make a line plot of the data. Make a line plot of the data. That's weird. I guess that makes sense. Really, we're making a dot plot, so that's why it's weird for me to read it that way. So it's okay. So now we have these pieces of data that represent all of these numbers. So I'm going to do the same thing. I see 1. How many ones do I have, though? I see 1, 2, 3, 4, 5. So I'll plot them. 1, 2, 3, 4, 5. Cool. How many 2's do I have? I see 1, 2, 3, 4, 5. So I'll plot them. 1, 2, 3, 4, 5. Cool. How many 3's do I have? I see 1, 2, 3. 1, 2, 3. How many 2's or how many 4's do I have? Just 1. Boom. Now literally the only answer choice that looks exactly like what we just built is going to be answer choice A here. Okay? Awesome. Now, just for an extra little tidbit of information, we should be asking ourselves, is this information skewed or is it symmetrical? And if it's skewed, which way would it be going? Well, if I am picturing this as like a roller coaster or a slide, and I'm having fun, woo-wee, which direction am I going in? I'm going to the right. So if I had to describe this particular data set, I would say that this is skewed. Right. Okay, let's keep going. All right, let's talk about number 6. The number of calls responded to by a paramedic team over an 8-day period are given. Use the data to make a box and whisker plot. Okay. Woof. Okay, well, we got to do some stuff. First things first, we have to put these numbers in order from least to greatest. So let's go ahead and get that done. I feel like I'm not going to have enough time. I have to pause it. But that's okay. We can do it later. Okay, cool. So let's put it in order from least to greatest. Sorry, guys. I see 6 twice. Good morning. I see an 8. I see a 10. I see a 12. I see a 14 twice. And I see a 15. So all these are very important, and it's important for us to put it in order from least to greatest because now we need to find some stuff here. So again, we have box plots, so we need those 5 points of information. I like to include the interquartile range, so I call it 6 points. Okay, so sorry about that. We have our minimum, quartile 1, median, quartile 3, maximum, interquartile range. I apologize. Sorry about that. Boop. There we go. Now, minimum's easy because it's the smallest number in our particular data set, right? So our minimum is going to be 6. Our maximum here is going to be 15. Cool. So that part makes sense. If we look at all of our box plots, every single minimum is 6. Every single maximum is 15. So we kind of have to keep going, okay? So now we have to find our median. Now, how do we find our median? We look for the number that's in the middle. Now, what happens if we have 2 numbers in the middle, like this? Well, we have to add those 2 numbers up and divide by 2. So if I add 10 plus 12, I end up getting 22. And if I divide that by 2, I really end up getting 11. So now I have my median. My median is 11. So I'm going to look at my answer choices and see if I can maybe find something different. 11, 11, 11, 10. Boom. So I know D is not going to be correct. I can cancel that one out immediately. All right. Now I'm just going to keep going, okay? How do I find my interquartile range? Well, here's the thing with this one. All right. Now that I have this number 11 here, okay, I basically have to include it. So I'm going to take this list and I'm going to rewrite it here. Okay, so and I'm going to include the number 11. So I still have the 2 6s. I have the 8. I have the 10. I'm including the 11. I have the 12. I have the 2 14s. And I have the 15. Now, I'm going to circle my median so I know it's the one that represents my middle. So how do I find my quartile 1? Quartile 1 is when you find the median of that first half of data. So the first half of this data, the median here is 2 numbers. So 6 plus 8 is going to give me 14. And 14 divided by 2 is going to give me 7. And 7 is going to represent my quartile 1. Quartile 3, I find the median for the second half of my data, which again is going to be 2 numbers here. So I have 14 plus 14, which is 28. 28 divided by 2 is 14. So now I know what my third quartile is, which is 14. In order to find my interquartile range, again, I do quartile 3 minus quartile 1, and 14 minus 7 is going to give me 7. So now I'm going to look at these box plots and see which ones make the most sense. I'm sorry. So let's go to A. Okay. Our minimum is 6. Quartile 1 is 7. Median's 11. Quartile 3 is 14. Maximum's 15. That looks like it works. So let's hang on to that for a second and then see what's going on with everything else. Minimum is 6. Quartile 1 is 7. Median is 11. Quartile 3 is 13. No, that's not true. Quartile 3 is 14. Minimum is 6. Quartile 1 is 8. No, that's not true. So our answer choice here is going to be A, and that's how we find it. Cool. Next one. All right, 7's not bad, okay? Basically, so they're talking about describing the shape, okay? And when we talk about the shape, we're talking about whether or not it's symmetrical if it's skewed, which means if it's leaning one way or the other, okay? So, I mean, just kind of use your eyes here and look at what you see. If I look at my box plot for number 7, I don't see a bunch of information leaning this way. I don't see a bunch of information leaning this way. Really, if I were to kind of split this box plot in half, I can say that this side is identical to this side. So, in that particular case, that means that it is going to be symmetrical. Now, we say approximately symmetrical because this is just like a visual example. I can't really truly say it's completely symmetrical. But if it looks like it's going to be the same on one side to the other, then we know that it's going to be symmetrical, sometimes approximately and sometimes exactly. Okay, let's go to the next one. Okay, number 8. Okay, so number 8, what we're going to do here is essentially we're going to make ourselves a dot plot, okay? But we're going to use ranges, okay? So let me show you what I'm talking about here. So I have my number line. I'm going to say that this is 0 through 9, that this is 10 through 19, that this is 20 through 29, and that this is 30 through 39. Okay, so I'm representing these ranges with this dot plot. Okay, now, in order to really kind of place these numbers where they need to go, okay, we do have to write them out in order from least to greatest. And so just bear with me because it's a fair amount of numbers when you start writing them out. Okay, let's get to it. Starting with, you see, let's do 0.1, and then we have 0.2, 0.7, 0.8, 1.0, 1.1, 1.3, 5.2, 5.9, 8.3, 12.5, 16.7, 28.2, and finally 34.6. Okay, so when we're talking about numbers that fall between 0 and 9, that's what we're going to focus on, okay? So let's see how many numbers fall between 0 and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 numbers here that fall between that 0 through 9 range. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, when we look at our answer choices, frequency is a word that represents how often that number appears. So just by doing the very first part, we see that it appears 10 times. Our answer is C. And if we plot the other ones from 10 to 19, that one only has 2. 20 to 29 only has 1. And 30 to 39 only has 1. Now, again, if I were to describe the shape of this data, I would say that it is skewed right. All right. Cool. Let's keep going. All right, number 9. Okay, number 9. It says, as part of a survey, a group of people were asked to name their preferred method of viewing television shows. And the responses are shown in the table. Okay, so we have 8 people who like to watch TV live, 9 who like to watch it recorded, 3 who like to watch on demand, and 5 who like to watch online, okay? So what we're doing here is we need to find 100%, but as a number. So 100% is going to be represented by the total amount of people that participated in this survey. So when we add this up, these numbers up, we end up with 25 total people. Okay, 25 total people. Okay, that's important because now we're going to find out how many in percentage wise, like what's the percent of 8 out of the 25 people who watch live TV. Well, let's do it. If I know it's 8 out of the 25, right? This is where we're using a couple different techniques. In my class, it's cowboy hat and horse, or T-bow, top in, bottom out, right? That way we know which number goes on the inside of our division boxes. So T-bow, top in, 8, bottom out, 25. So here we know that 25 cannot fit inside of 8. So we do a 0, decimal, 0. Well, 25 can fit inside of 80 3 times. That's going to give us 75. Difference here is 5. 25 can't fit into 5, so we add a 0, bring it down. 25 fits into 50 twice. In order to see what that looks like as a percentage, we swing that over twice. Boom, 32%. So we know that 32% of people watch recorded television. Or live television, sorry. So then when we look at our answer choices, I'm looking that I can keep answer choice A because that's just above 30. Answer choice B says 30 exactly, but I know that people watch live TV 32%. C says 25%, which obviously is not true, and D also represents 32%. So now I know what my next two answer choices are ultimately going to be. Now let's figure out how many people watch recorded TV, right? 9. Again, 9 out of the 25. 9 out of the 25. So again, this is that top in, bottom out, where we have 9 on the inside, 25 on the outside. Now 25 good morning, 25 cannot fit in the 9, so I put a 0, decimal, 0. So 25 fits in a 90 3 times, that's going to give me 75. Difference here is 15. Add a 0, drop it down. 25 will fit into 150 6 times. So again, swing it over. That's your percentage. 36% of people watch TV that's recorded. Now, if we look at answer choice D, from 32, it looks like to about 45. That does not represent 36%. D is wrong. A is correct.